In this video, we're going to be continuing our work on radians by looking at small angle approximations when the angles are measured in radians. Consider the diagram below. OAB is the sector of a circle of radius r. AC, the line AC, is tangent to the circle, so therefore we've got a right angle there. And by using trigonometry, we can see that AC is going to be equal to r tan theta. Now we're going to look at three different areas. The shaded triangle, OAB, the area of that is half r squared sine theta, using our trig rule for calculating the area of a triangle. The area of the sectant, area is half r squared theta, using our rule for radians. And the big triangle, half base times height, so the area of that is going to be half r times r tan theta, which is a half r squared tan theta. Now look at these two diagrams. Look what happens as the angles get smaller. You can see that the areas, the three different areas that we just talked about, will get closer and closer together. So that means we can say that the areas are approximately equal to each other. Simplifying that expression and rearranging it, and we end up with the result that theta is approximately the same as sine theta, and it's approximately the same as tan theta. That is our first small angle approximation. Now consider this diagram. This time we've got a circle which has got a radius of 1. And using that bit of information, we're able to work out the length of two sides OD and BD just by using trigonometry. And therefore we know that AD is 1 minus cos theta, because we know the whole length from O to A is 1. The arc length, using our rule for radians, is r theta, which is 1 times theta, which is theta. And then by Pythagoras' theorem, we can work out what the length AB is going to be by using the triangle ABD. And so we get AB squared is equal to sine squared theta plus 1 minus cos theta all squared. And by expanding this and simplifying it, we can end up with an expression for AB squared. So AB squared is equal to 2 minus 2 cos theta. Now look at the diagrams below. Notice that the arc length AB and the chord AB get closer and closer in size as the angle gets smaller. So we can say that the chord AB is approximately the same as the arc AB. Using this information and the previous results, we can write that theta squared is approximately the same as 2 minus 2 cos theta. And then rearranging this to get cos theta as the subject, we get cos theta is approximately 1 minus a half theta squared. This is our third small angle approximation. So these small angle approximations will be given to you in the formulas on the question paper, and they're pretty well valid between theta is between minus 0.1 and 0.1 radians. So here's a typical example. The first thing we're going to do is we've got to write 1 minus cos 3 theta using the small angle approximation. Now the trick here is that 3 theta is our angle theta, so we replace the theta in the formula with 3 theta. And then we just simplify the formula. So carefully going through this one, you end up with 9 theta squared over 2. The next thing I'm going to do is I'm going to work out what 1 minus cos 3 theta over 4 theta tan theta is. Again, using the small angle approximations, I've already done the top bit, so the numerator, so the denominator, well that's 4 theta times theta, which is 4 theta squared. So when I simplify this through, I get 9/8. And then in the limit, so just to write out the final answer, I can say the limit as theta tends to 0 of that expression is going to be 9/8.